This is a video about the notes how to do heated reaction, program 33, and you should have watched the other videos. I'm just going to summarize all the information in one shot. So here goes. First of all, when when a reaction happens, heat is either given off or it's absorbed. If it's given off, it gets hot. That's exothermic. If it doesn't release heat, it absorbs heat. It gets cold. It absorbs heat from the environment. So the heat of formation of a chemical substance for a compound is the heat either absorbed or released when it's formed, but there has to be a definition of zero. So the heat of formation of elements are already formed by Mother Nature or God or whoever you want to call it. They're already formed. Diatomic gases and elements like O2, N2, and Cl2, they're in their standard state as gases. Iron is an element, but it's solid, and argon is a gas, but it's a noble gas, so it doesn't have a subscript. So you should know how to identify elements already. If a chemical reaction gives off heat, the graph looks like this. It goes down. The reactants have a higher energy content than the products. They release heat. Delta H is negative, gives off heat. So the reverse is the graph goes up because you're adding heat. When you add heat, it absorbs heat from the environment, so the substance gets cold. So delta H is positive, adding heat. All right, that's pretty straightforward. So I'm going to minimize that. And you should have this table on your notes somewhere. So this is the table of heated formations. Delta H F0 is standard state. And you notice you don't see any elements on here because they're all zeros. You don't need those things. Ozone O3 is not in its standard state, so it does require some energy to form. And that's how the ozone layer is formed, by rays from the sun hitting oxygen, and it kicks another oxygen into the chemical formula. And we've talked about ozone having different shapes than oxygen molecules. Okay, so there's the heat of formations you're going to use to look up when we do these heat of formation practice problems. So here is one. And today is, I'm making this video on April 3rd. It's Friday. It's kind of chilly. So my heater kicked on. It was chilly outside. My heater kicked on, and most of us have a natural gas heating system. So it burns CH4 with oxygen, makes CO2 and water. And we've balanced this formula many times in the past. Today we're finding the heat, not the molar masses, not the grams and moles, but we're finding the heat of reaction. And the heat of reaction is the sum of heat of formations of products minus the sum of heat of formations of reactants. So you're going to add the products and then subtract when you add the reactants. So these are the products. And over here, there's 2 moles of water. So we're going to multiply the negative 286 kilojoules per mole times 2 moles. For the CO2, it's just 1. So blah, blah plus blah equals negative 965.5. And 2 times 0 plus negative 75 times 1 is negative 75. The only way you can screw this up pretty much is if you forget to multiply by 2 and forget to minus a negative. And that's a 9th grade Algebra 1 problem. So please don't forget to minus a negative. And when you do subtract those, you get negative 890.5 kilojoules per mole. And that's a lot of heat released. And that's why all combustions are negative, because they give off heat. That's why we burn stuff to get warm. Here's a not as good drawing, but I just put it down there because it was right there. So endothermic goes up, exothermic goes down, releases heat. Okay, we've done one. You've watched me do one. Now, you're going to pause this video and you're going to do this problem. It's the same type of combustion, but ethane has a different molar ratio in here. So pause the video. Beep, beep, beep. Okay, so you should have worked that problem. And here we go. It's going to be the products minus reactants, except this time it's 4 times CO2 and 6 times liquid water minus 7 times 0 and 2 times negative 84.7. And this is negative 3290 minus a negative 169.4 for a total of negative 3120.6. And you may say, well, yeah, it's going to be more heat because it's a bigger molecule. And it is. But it's also for 2 moles. So if we want to compare apples to apples, then the energy content in 1 mole of ethane is negative 1560.3 kilojoules per mole of this, when CH4 up there was like negative 890.5. So why is it different? Because there's more CO2 molecules and water molecules being formed. It's releasing more heat. It's not a 1-2 ratio, it's a 4-6. So because there's more carbons, there's more energy content, and that's why we use octane C8H18 for car combustion. All right, so that was a good attempt. Now, if you haven't already worked the programs, this is a good way to give you a help on finishing the rest. Okay, good luck. Thanks.